All right, Geometry Advanced, we are going to start going through this review guide for Chapter 8. My plan is for today's video to be over the first 2 pages. Tomorrow's video will be over the second 2 pages, or pages 3 and 4. And I believe that last page we don't really need a video for, but if you have questions about the definitions or the properties on that very last page, you can send those to me. But you should be able to find all of those answers in your notes. All right, so starting with number 1, the formula for finding the sum of the interior angles of a convex polygon is n minus 2 times 180. That's the sum of all of them. The sum of the exterior angles of a polygon is 360 degrees. All right, find the sum of the measures of the interior angles. So if it says the sum, we just need to use that formula from number 1. A dodecagon has 12 sides, so n equals 12 in this case. 12 minus 2 times 180 gives us 10 times 180, so 1800 degrees. A 40gon, of course, means that n is equal to 40. 40 minus 2 times 180 gives us 38 times 180. And that would give us 6,840 degrees. The sum of the measures of the interior angles are given. Classify it by its number of sides. All right, so the sum is given. So this sum, 2,520, is equal to n minus 2 times 180. In my opinion, it's easiest to solve these by first, let me just make a little space down here. First, dividing both sides by 180. So if we take 2,520 divided by 180, we should get 14. On the other side, those 180s just cancel out, so we just have n minus 2. And then we add 2 on both sides. We get that n is equal to 16. Of course, they didn't just want n, they wanted us to classify it. So this one would be a 16gon. Okay. Next one. Same setup. 5,940 equals n minus 2 times 180. Divide both sides by 180. This time we get 33 is equal to n minus 2. We still have to add 2 to both sides. So here n would be equal to 35, or we would have a 35gon. Okay, pause the video here if you need more time with those problems. I'm going to scroll down. What is the measure of each interior and each exterior angle of a regular nonagon? Okay, well, if we want to find the sum of all the interior angles for a regular nonagon, nonagons have 9 sides. So 9 minus 2 times 180, 7 times 180, gives us 1,260. So that's the sum of all the interior angles. I just want each interior or one interior angle. And if it's regular, that means it has to be equilateral and equiangular. So I can take that sum and divide it evenly by all 9 angles that a nonagon would have. So we divide by 9, and each one should be 140 degrees for the interior angles. We also want to know the measure of each exterior angle. For any convex polygon, the sum of the exterior angles is 360. We would again divide that by how many angles there are, and we would get that each exterior angle should measure 40 degrees. You should also know that an interior angle and an exterior angle should be supplementary to each other. So if you do problems like this and you don't get an interior and an exterior that add up to 180, something's wrong. All right, next up, we've got some polygons. We are trying to find the value of x. Number 8 should be pretty easy because this is a quadrilateral. You should know that the sum of the angles in a quadrilateral are 360. So we just need to subtract off those angles that they gave us, and that will give us our leftover angle. When I subtract all of those, I'm getting 83. So that's what I believe x should equal for number 8. Number 9 is a little more involved. This time we don't have a quadrilateral. Instead, we have a pentagon. We've got 5 sides. So this time we would first need to do n minus 2. So if n equals 5 here, 5 minus 2 times 180. That should give you 540 degrees total. So if we were to add up all of these angles, it should equal 540. So I'm going to kind of combine like terms as I go, meaning I know the 5x and the 9x will get added together to give me 14x. Plus, I need to add up all the angles that are just whole numbers. So that gives me 302. And that gets set equal to that sum of 540. So 14x plus 302 is what I get when I add up all these angles in here, combining like terms. And I know that the sum of all the angles should be 540. Then we just need to solve 540 minus 302. And then divide that by 14. So 14x equals 238 after I subtract. Divide both sides by 14. We get that x is equal to 17. And that's all they wanted, was the value of x, so we can stop there. If they had wanted the value of the other angles, we would have to plug 17 back in. All right, number 10 is a little bit different. This time the angles are on the outside. Let me make a little space over here where I can show some work. If the angles are on the outside, then we know that the sum of them would be 360. So I don't even care how many angles there are. I just know that they're going to add up to equal 360. Again, I would recommend combining like terms when you do this. So start by finding all the ones that have an x in them. and add all of those up. So 52x plus, now just add up all the numbers. When we add up all those constant number angles, we should get 204. Then again, we just need to solve for x. So 360 minus 204. And then we divide by 52. We should get that x equals 3. All right, again, pause it here if you need more time with these problems. I'm going to move on. Sorry about that. Laptop's being a little temperamental. All right, on to 11 and 12. We are looking for the values of the variables. We are told that these are, in fact, parallelograms, which is important to us. So if we have a parallelogram on number 11, we know that opposite sides are congruent. So those two sides are congruent. That means c squared should equal 25. To get c alone, I would have to square root both sides, and we would get that c equals 5. Pretty straightforward. We also know in a parallelogram that opposite angles are congruent. Therefore, d plus 15 should equal 68 because they are opposite angles. They're across from each other. So to solve for d, we just need to subtract 15 from both sides, and we should get 53. All right, on number 12, we need to find x first. They have only labeled the diagonals for us, but that's fine because we know that in a parallelogram, the diagonals bisect each other, which means this part of the diagonal is congruent to this part. If we move to the other diagonal, those two parts are congruent to each other. So we can find x using that first diagonal that I marked. 3x minus 7 equals 2x. Doesn't really matter to me which way you go about your algebra. I would subtract 2x from both sides and add 7 to both sides, which would give me 1x is equal to 7. Once I do that, in order to find y, I know that y is going to equal x plus 1. Luckily, I just found x, so I can plug that in, and 7 plus 1 is 8. All right, several people asked me about 13 and 14, so let's start with 13 and then I'll scroll down and do 14. On 13, the perimeter of parallelogram EFGH is 16 inches. You need to know that to find perimeter, you would add up all the sides. So we'll come back to that in a minute. Why don't we go ahead and just construct a little parallelogram here. It's not bad. EFGH. We are told that EF has a length of 5 inches. Just put a 5 there. Find the lengths of all other sides. All right, well, one of these sides should be pretty easy. In a parallelogram, opposite sides are congruent. So that means that GH is also going to have a length of 5. We know that FG and EH should have the same length, but we don't know what it is yet. So for right now, I'm going to label them with X's because I know they have to be the same, so I label them with the same variable. Okay, let's get back to that idea of perimeter. Perimeter means you add up all of the sides, and that's how you would find it. So if we add up 5 plus x plus 5 plus x, that should give me my perimeter of 16. Okay, we're back to some pretty basic algebra. 2x plus 10 equals 16 if I combine like terms. Subtract the 10, 2x is equal to 6. Divide by 2, you get x is equal to 3. And so then really we're done. You would either need to go back and label your diagram with 3's instead of x's, or you could just write your answer off to the side. GH had a length of 5. EH had a length of 3, and FG had a length of 3. Those would be my answer. Okay, again, pause, write down or email me questions if you have them still about that problem. Scrolling down. All right, I also had people ask me about number 14. So 14, we will also be using our ideas of angles inside of a parallelogram. So still working with those properties. Let me make a new parallelogram. It's pretty good. This one is JKLM. We are told that the ratio of the measure of angle J to angle M is 5 to 4. Find the measure of angle J and angle M. If our sides are in a certain ratio, that doesn't necessarily mean that angle J has a measure of 5 and angle M has a measure of 4. It means that they need to be multiples of 5 and 4, so that if we were to put them in a ratio, it would reduce down to 5 to 4. Meaning 50 and 40. If we put those in a ratio together, 50 over 40, it would reduce to 5 to 4. However, it's not actually going to be 50 and 40. That's a little too easy, but also because they don't add up to 180. Remember that consecutive angles inside of a parallelogram have to be supplementary. So since we don't know exactly what we're multiplying 5 and 4 by yet, we use an x. So we can label 5x and 4x. This still allows us to divide them and get 5 to 4 as our ratio. But this also allows us to set up an equation. We know that 5x plus 4x must equal 180 because, again, they're consecutive angles. They're right next to each other. They have to be supplementary. We can combine like terms and solve this pretty quickly. We get that x equals 20. They did not want to know what x is, though. They wanted to know the measure of angle J and the measure of angle M. So the measure of angle J is found by taking 5 times that 20, which is 100 degrees. The measure of angle M, we would take 4 times 20 and get 80 degrees. So those would be those two angles that they asked us to find. Again, they add up to 180. If you take 100 divided by 80, you would get the reduced fraction 5 over 4. All right, last set of problems for this video. We have another parallelogram. We are given some information about it, so let's try to label that before we get to the questions. Angle KHI, so KHI is the big angle up here, and that measures 84 degrees, so this whole angle is that 84. The measure of angle JKI is this little angle right here, is 28 degrees. GI has a length of 7. GJ has a length of 8. And they've also labeled some other sides for us. IJ is 10, KJ is 16. All right, with all of this, we need to know the length of HI. That one should be easy. It's opposite KJ. Opposite sides are congruent. So 16. KH is opposite IJ. Those have to be congruent. So 10. GH is part of a diagonal. Remember, diagonals bisect each other, so GH and GJ should be congruent. 8. HJ gets a little more interesting. HJ is the whole diagonal there, so 8 plus 8 would give me 16. Okay. Moving right along, we've got the measure of angle KIH. I think that before we fill these in, maybe it'll be easier if we just talk about it in the context of this parallelogram, and then we'll work on which answers go on these blanks. Okay, so to do this, I'm going to take away those diagonal measurements because we don't really need them anymore. One thing I want to remind you about is that the big angles, like the whole big angle at H that was 84 degrees, that's going to be congruent to the whole big angle at J. So if for a moment we act like the diagonal is gone, this angle down here is also, 84 degrees, which would allow us to find the small angle up here at I, just this little one. So this little angle in here I could find by taking 180 minus 84 minus 28. Because now I'm just looking at this triangle. Okay, so if we take 180 minus 84 minus 28, we should get 68 degrees right in there. Okay, the other thing I want to point out is that any consecutive interior angles should be supplementary, which means if I were to add up, for example, this angle at J and this whole angle at K, it should also add up to 180. Which means that this small angle over here that's missing is going to also be 68 degrees. Okay, if you have 3 angles inside of a triangle, they add up to 180. That's how we got the 68 here. These 2 big angles have to be supplementary. So that's how I got the 68 here. Because all 3 of these pieces, this big angle and the 2 pieces that make up angle K, have to add up to 180. Okay, so we're getting some stuff filled in. I feel like I can bring back part of that diagonal now, maybe not all the way through. So let's see if that kind of gives us enough to get started with our blanks over here. So if we're looking for the measure of angle KIH, KIH is this little piece up here. Well, if we know I and K, those big angles, are congruent, then that means that KIH would also have to be 28 degrees, right? The big angle at K should be the same as the big angle at I. So we would add those two together, add these two together. It should be the same thing. So KIH is 28 degrees. Another way that you could go about reasoning about why these both have to be 28s would be to use your transversals. Sorry, your parallel lines with its transversal. Okay, if you look at these parallel lines and the transversal cutting them along the diagonal, these are alternate interior angles. They have to be congruent. So there are a couple different ways you could reason through that problem. JIH. Well, we already found the two pieces. We just need to add them together. So 68 plus 28 would give us 96. A different way you could reason through it would be to take 180 minus 84, since these two big angles have to be supplementary. Angle KJI, well, we already labeled that one 84 degrees because it's opposite the big angle at H. So 84 degrees. And HKI. So HKI, that's one of the ones that we had labeled while we were going through this as being 68 degrees. Again, a few ways you could reason through it, one of them being that we subtract the two angles we'd already found from 180 since they're all supplementary, or you could use your transversal again, and again we've got alternate interior angles here. Okay. Lots of different ways to get to those answers. The big ideas you have to remember would be opposite large angles are congruent. You could remember your alternate interior angles if you like to use your parallel lines in the transversal. Consecutive interior angles are supplementary. All these ideas. Okay, so that's pages 1 and 2. Tomorrow there will be a video for pages 3 and 4. Make sure you follow the directions in the assignment for each day as far as me knowing that you're participating. And I will talk to you guys again tomorrow.